No? Yes, no? Some sort of cruel joke? Okay, may as well. Hey everybody, welcome to EdinburghJS. Another great turnout. Thank you for coming out this evening. It's nice to see familiar faces, faces from Glasgow who are here all the time, which is nice, and new faces as well. So thank you for coming out. I think it means a tremendous amount to be able to run events like this and have speakers share their knowledge. So tonight we've got two speakers lined up for you. Before that, I would like to say a couple of words of thanks. First is to FanDuel for giving us the venue for free. It's a really great space, so thank you to them. Thank you to KPV LAB for sponsoring, and thank you to McGregor Boyall who are sponsoring as well. Is anyone from McGregor Boyall here tonight? No, so the person I'm speaking to from McGregor Boyall was in a tennis tournament today, so she wasn't able to make it. So I don't know if anyone else, so good luck, however that went. So thank you to them for sponsoring as well. Next month, we've got Daniel speaking. I will push the notification for that. So if you want to get in on that, just check your phones after the talks, wherever Daniel is. There in the audience. Cool, so thank you for that. I will send the notification during these talks. Cool, so first up tonight is Joe, who's going to be talking about an exciting framework, Astro and Astro Islands. Take it away.
All right. Hello, everyone. Hi. I'll try and speak up as well for people at the back. And as far as I know, the guy with the microphone isn't running at me, so that's good news. So, my name is Joe. I'm a full-stack developer. I currently work at a chicken restaurant that you may have heard of. And I've only worked there for a little while, but I've been a front-end developer for about 12, 13 years, somewhere around that point. But decided screw it, I'm going to go into full-stack. So that's what I did. And what's coming up today is I'm going to be talking, first of all, about Astro Islands. First of all, why islands exist, the islands architecture itself, and what it means exactly. And then I'll go into a bit about Astro itself, a demo that will, fingers crossed, still be working now, and then bits and bobs after that. So I'll be talking about islands. It's an architecture principle that Astro largely pioneered when it came out in about 2021-ish. But it was utilized in other frameworks as well before that, just sort of indirectly sometimes. And it was actually indirectly conceived in the days of jQuery, so the cool, good old days before Jamstack came along. And the reason why it's come about is because of a concerning trend about the amount of JavaScript that is loaded per website, which has been increasing steadily over years. This is an output from a report called the Web Almanac, which is a yearly report, and it collects lots and lots of data from as many websites as it can. And one of the statistics that it gets is the amount of JavaScript that is sent to individual web pages. And as you can see, over each year that they had it on both desktop and mobile, it was increasing each year. They haven't released the most recent one for 2023, but that's up to 22 at least. So let's go into why exactly this is a bad thing. Because it results in increased page loading times in order to actually download that JavaScript and then parse it. It blocks the rendering of other page content that you have on there. And it's a higher resource usage. You may find that if you're on a phone, for example, if you've got a lot of JavaScript that's coming in, that's using up battery resource and CPU resource. And so I'll go on to the two main JavaScript UI main players in this cave. So they've carved a fairly dominant position, both of these, in making websites, especially since single-page apps were introduced. And the thing is, for React and Next.js in particular, they do ship a lot of JavaScript, even with server-side rendering. And they both have these typical approaches that they take for rendering. I won't go too far into them, because I think Phil will go through some bits. But the main two that I'm going to touch on are client-side rendering, which is CSR, and server-side rendering, which is SSR. And I thought I started to make a diagram about client-side rendering and going through it, which is used by React and other frameworks like Angular and Vue. And then I decided not to, basically because it's not brilliant to do, except in a few cases. So the times when client-side rendering is a good thing to do is when you have a JavaScript-heavy page in itself, like a dashboard or a mapping application, something where it's basically expected, it's a highly dynamic page. But otherwise, for other websites that are a bit more in the middle or mainly content-driven, it doesn't make as much sense for your UI to be rendered on the fly. So I thought I'd go more into server-side rendering, which is something that Next.js really popularized when it came out. And essentially, how that works is that the page is rendered, it's pre-built, the HTML is pre-built, either at build time or on the server itself. The browser then downloads that. When someone goes to visit that website, the browser then downloads that JavaScript and executes everything in it, including React. And then the page is then hydrated, which means it's going through the page to find the interactive bits and then making them interactive, and then that's it. The page suddenly starts working. And the benefit mainly of server-side rendering over client-side rendering is this bit here. It's basically where the HTML has already been sent over to the browser, so therefore the user can actually see something on the page before the JavaScript then kicks in, and that's good. Well, better. And through approaches like CSR and SSR, it really shifts the responsibility of parsing your UI to your browser, which is fine if you've got an M2 Pro or an M1 or whatever, or a really good phone. But for those with older machines or older phones, or machines already running Slack or any other intensive program, it can be quite difficult to take in. And I tried to find an image that was a good analogy for basically being in the middle of nowhere. And this is the best thing I could find. So you know when you've broken down and you're in the countryside and you can't get any signal, and you're really stuck, and you're just trying to get that cooking website to really load. Like you need to sort out how to make that pavlova later. It just won't. But basically, the analogy is that it's intended for people, even if you're in spotty signal. As quick as you can make your web page to load, the better. And I realized the irony of coming to EdinburghJS to say, use less JavaScript, don't do it. But I'm not coming here to say that JavaScript is necessarily bad to use. Even with CSS progressing in the way that it is, we still need JavaScript for a lot of the work that our websites demand. And we as developers need to write and distribute JavaScript more responsibly because we need to think of how the users will be consuming that, and therefore how it will be consumed, basically. Which brings me on to islands. I'm flying through this because I did a test and I overran the time limit, so I'm trying to make sure that I don't waste any time. But islands are basically a principle of only shipping the JavaScript for specific components of a web page. So what does that mean? So since we're in Edinburgh, I thought, let's grab a website. And I thought the Hearts Football Club website would do. Sorry to any Hibs fans here. And there are some areas of this site that I thought stood out a little bit. If I highlight the parts that are just entirely static, basically images and text, it makes up most of the web page. Especially as you scroll down, there's just more images and text, basically. The only bits of this that actually need JavaScript are that carousel, it's moving over and then showing a video or something, and the nav bar at the top, which when you hover over it, then it displays more links underneath. Those are the only two parts. And if you were using Next.js, it would be basically sending all of that, all the HTML, but then none of the page is interactive, rather than just the bits that actually need to be interactive. And that's the sort of difference of islands. It's the whole point of it is essentially it's a sea of content, whether it's images or text or anything else static. And the islands are basically the unique dynamic components that are inside that sea, that are in that sea. So the only difference is instead of beaches and cocktails, we get carousels in 2024. So islands are really cool for that, but they also don't depend on each other, and yet they can share state. So by not depending on each other, that means they can be loaded in parallel. And using custom events, which is really cool, it's a browser feature, or you can use a third-party dependency like something called nano stores. You can share the state between these components so they're aware of each other. And yeah, as I say, only the islands need to be hydrated, not the whole page. So if we visualize it just a little bit, Next.js needs to go through the whole app and actually hydrate the whole page, whereas an islands architecture, such as in Astro, it only hydrates the bits that it needs. And this flexibility also means you can load islands dynamically according to how they're actually used or needed. So for instance, we've got the browser up here is displaying the content that's above the folds, i.e. Above the bottom of the browser. But there's this island down here. And we don't need to load this as soon as the page, as soon as the user lands on this page, because it's not even visible yet. And so we can do something cool with it. We can say, load this island when the page loads, because we do need that. That's instantly visible. But this one, we can just load it when we actually get to here. Cool. So how can I use islands? And that's when I introduced Astro. It's my favorite web framework at the moment. I've flipped between favorites, I will admit. Next.js was my favorite at one point. And I'm also aware there was a workshop on this at EdinburghJS before. So I'm going to try and just provide the highlights. And I will start to sound like an Astro salesman as well. I will try to start to sound like that, but I'm not actually part. Not yet. So anyway, it's a web framework. It was introduced in 2021, and it made some pretty wild promises when it came out. First of all, it's a web framework for creating content-rich websites with performance at its core. And I'll go more into why or how in a second. It has support for all your favorite styling strategies, whether that's Tailwind or PostCSS or Sass or just plain old CSS. And it has a huge focus on developer experience. It has some really nice dev tools. The stuff that it supports out of the box is really cool. Astro is server first, which means by default, Astro renders everything to HTML, all of it. Even the JavaScript stuff that you have on there, by default, it will try and render that to HTML. And if you don't instruct Astro that you do actually need that JavaScript, it will just ignore it. It won't use it. So by default, it runs on the server, and that's it. If you know what static site generation is, it's basically that. And it can be configured to pull things from a server at the point of the website being built while it's been deployed as well. So that could be like content from a CMS. It pull that data in, build the pages at that point. It also supports other things like on-demand rendering, which is when someone has requested a page and you need to get content at that point. It also does that. So it generates everything on the server just as you're visiting it and then brings it back in, which gives this result. As I say, by default, Astro ships no JavaScript, and you have to tell it when you want actually any JavaScript. So as I say, when Astro got announced in 2021-ish, it made a really, really bold promise. It said you can mix and match your favorite UI frameworks. React is technically a library, but I call it a framework. But you can mix it as well with Vue, Svelte, Solid. The other ones are Quick and I want to say Preact, I think. But basically, you could just mix and match them as you like. Someone did ask why you would want to do that. And the main reasons for me are when you're trying to migrate from an existing website, it's useful that it actually supports that. Chances are you may have a React website that you want to migrate over. So the fact that it supports that is great. But then you can also migrate over to another language if you had that in mind. Or you can use it for just like basically get to know another framework as well. So it's really cool in that way. I definitely have wanted to try Svelte for ages in a production website. It would be lovely if I had an Astro website. And Astro allows you to hydrate islands when they are actually needed. So that example that I displayed of the below the fold thing, you can do that using something they call client directives, which are basically attributes that tell a UI, a client component, what to do. So I've got some examples here. So first of all, carousel, everyone's favorite element. If you don't provide any kind of client directive, which is these other attributes, it won't do anything with that. It won't bring any JavaScript with it. It will just render the HTML as it is, and then that's it. But as soon as you tell it, hang on, I want you to just load immediately. Then that's how you do it with this one. You can give this attribute, and it will load that JavaScript as soon as you load the web page. You can also tell it when the browser is idle, i.e. it's not doing any expensive operations like running animations or trying to figure out the layout or stuff like that, then load the JavaScript as well. So it's sort of just deferring, loading, and passing the JavaScript, and then taking the burden off of the browser a little bit. My favorite, definitely, is when you actually get to that component. Actually, since you're actually going to be using it at that point, that's when to bring in the JavaScript. And you can also tell it even a media query. So you can say, only on mobile, I want to load this JavaScript, or only on desktop, which is really useful for elements like a burger sidebar. That would only be rendered on mobile, so it only makes sense to give that JavaScript to mobile. It might still be better to use CSS, but the option's there. Right, OK, let's see how this goes. So I have got, I've basically built up this whole web page here. It's a microsite that I've deployed with Netlify, which is and essentially it's to try and demonstrate everything about Astro. What I'm going to do first is that I think this is the one that I've got. Yeah, so this is the one that's actually deployed. It's actually on the internet. You'll be able to see it afterwards. And as you can see, I've loaded this web page, and JavaScript is empty. There's nothing there. So everything so far is static. As I scroll down, I've got loads of content about why you would use islands, what they're good for, that kind of stuff. As soon as you get down, though, oh, shoot, I've just realized I'm not connected to the internet. Right. Hold on a sec. I told you things would go wrong. OK, right. Let's try this again. OK, so refresh. Uh-oh. I've got a backup plan, so don't worry. I'm talking to myself. OK, am I connected now? Right, so let's try that again. Just forget what happened. So, so as you scroll down, it's still all static. Everything is just plain text or images or code. But then as soon as we start to get towards the little demo section that I've got here, I've tried to style the things that are actually islands as islands in a sea of content. That was really satisfying. And then I've also added an icon to actually show which framework I'm using for this island as well. So in this case, these logs, I'm going to be sending a log to it as other islands load. What other islands, you ask? I'll show you. So this one I'm loading with Svelte, and it's basically just picking up some logs from others. So at the moment, nothing's happened. If I keep going, keep going, keep going, I'll get there eventually. So that little graph that I had at the beginning of the presentation, I thought I would actually make a JavaScript graph. And here it says, oh, it's been rendered and animated. And I wrote this one using React, because that's what I'm most comfortable with, really. If I keep going down, then this one calls to an API that I've got that says, that tries to grab my top songs from Spotify at the moment. Luckily, they're not too embarrassing at the moment, but I do have a 4-year-old, and she keeps listening to Lilo and Stitch, so I had to really cultivate this to not display Lilo and Stitch. But anyway, as I say, as I've fetched these tracks, I had a little log in there that sent it over to here. So even though this is a React component, it's talking to a Svelte one. Sorry, that's a Svelte component talking to a Svelte one. And then the final thing is I've got some colleagues here from KFC, and they really kindly made this little ChatGPT API, which basically takes my top songs, so these top songs, and asks ChatGPT to make something from them. So I asked them, could you make another song that's punk rock? And it did it. And then it takes a little while to load, so just so you know. So I've done a song so far. I'm now going to ask it to generate a poem based in Edinburgh, and that's when it does that as well, which is nice. And it has these, it's peppered in the song titles. But yeah, so, and as you can see, added a new log in there. And this one was really cool as well, because the client visible directive, I used that one, but I also told it, only use the margin, apply a margin over it. So as you go closer to the component, if you come within a sort of boundary around it, then that's what it classes as being visible and then loads it at that point. So, and I did that because the ChatGPT API tends to be a little bit slower. So I thought, oh, get a little head start on that. And that's it, that's the demo. This took me ages. Thank you. I'm now going to sum up a little bit. So especially because that went okay. So as I say, JavaScript is not bad. It's a good thing to use. It's really, really essential for a lot of things that we still do on the web. And the islands architecture, though, the whole point of it is to try and minimize it. It's to try and take off the burden off the user and make a website quicker to load and use. Astro is definitely not alone in this space. Fresh, which is a Dino framework, uses the exact same thing, uses islands. Marco here is something that was built by eBay back in ages ago, basically. And it uses something called partial hydration, which is basically the same principle. So even though that's existed for ages, not as many people have heard of it, such as React. But it has big performance benefits to it. And some of you may be aware of something called React Server Components and may be thinking, what about them? Aren't they basically the same thing? And the answer is sort of, not really. They are a step in the right direction, definitely, because they take a lot of the burden off the browser, as I've said. But they arguably don't do enough still. Essentially, it's becoming a bit more well known that essentially when you load a React site that is using React Server Components, it's still rendering a whole lot of JSON and JavaScript for that. So it's not really doing the right thing there. Well, it's not got the same kick to it. And that's why Astro does have that kick. So do give it a go. I think you will enjoy it, especially if you're just like developing for the web in general. And that is me. Thank you.
Thanks, Joe. That's great. I always think it's funny, like having the favorite framework, because I'm like, Astro's my favorite framework because it's what I migrated my website to, a couple of months ago. In a few more months, who knows what it'll be? So really good. So, do people have questions for Joe about Islands architecture, Astro in general? I guess. Yeah. I've got some stuff here. This is for the live stream, so you won't be able to.
Thanks, very clear talk. Fantastic, thanks. What kind of impact does that have on server-side load in terms of, does it have much of a difference? Or?
So I wouldn't say it has a noticeable difference, no. It definitely could, and especially if you're going off to other places to get data from it, then depending on how quick that data is to retrieve, then it could impact it in that way. But in general, rendering any kind of content is always going to be quicker on a server because it's got so much more resource to use. So there shouldn't be. If there is, then it might be a sign that something external is affecting it.
Any more questions? This side of the room, Victoria's poised, ready to take a question. But
Thanks for the talk. I have 2 questions, maybe 3. So how each component isolate, or are they isolated, the components, or somehow encapsulated? And if yes, how they share the context or the vendors or any other stuff?
Yeah. So the question is how the components are encapsulated, or how they basically don't bleed into others, and then how they talk to each other. So the example that I've got, actually, I guess I could get away with this. Hold on. Maybe I'm playing with fire here. But basically, in my islands directory, these are all the islands that I've got. So there's the ChatGPT one, the logs one, graph. Essentially, because I've put them into separate files, that's when Astro is able to keep them separate from each other. And then you can communicate with them. What I've used is, doesn't display it. Oh no, here, sorry. I've got my shared file, which is basically containing all my logs, and it's using a package called nanostores, which essentially kind of keeps it in the browser context, so window context, and that's how it communicates to each other. And they also use something called custom events, which are basically creating your own browser event and then being able to listen to that event, just like a click or whatever. Does that help?
Yeah. And what about because now I see you have kind of like one component per island, right? Kind of how it compiles or transpiles the code.
How it compiles and transpiles. So I think it uses...
For example, you have Svelte, right? It needs a
Yes.
compiler.
Yes.
So can you use straight, like just import inside of the Astro and use the Svelte, or you need to compile it and then use?
You can use it straight in. So when you're in dev mode, it all uses Veep behind the scenes. So it's basically keeping a copy of whatever framework it is, whether it's Svelte or whatever, and then it's using that in order to render it. And then when it's actually deployed, what it does at that point is when it renders the island, or when it picks up that the island is loaded, it also grabs the framework and puts that just above it as well. So it's getting everything at that point. But at least at that point, it's when the user actually needs it rather than as opposed to not needing it yet.
Okay. Yeah. No third question. Cool. Anyone else? Back?
You mentioned a lot of the driving forces device driven, so having a high performance device means you can do all the JavaScript and stuff client side and that sort of thing. Is there any sort of ability to look at that in Astro and say oh, if the device is above a certain level performance wise, then you can actually load all this stuff ahead of time and it's all good? Because the thing I find confusing is if you load it based on visibility, there's still going to be a delay in the downside and stuff like that.
Yeah, good point. So the question is, how can you actually test it if say, you want to make sure that the website is still good for a slow-performing device or bad internet connection? How can you make sure that it is actually good for them? Is that right? Yeah. So I wouldn't say there's any tools in Astro to do that, but there definitely is in the browser. If you use DevTools, you can set it to throttle the connection, so you can mimic what it's like to be on a slow 3G or fast 3G connection, and then it will intentionally download resources slowly, so then you can see how that looks to the user. What if your device is actually offline as well? You can set that, and then it will, it will sort of mimic it. So it's kind of a pretend, it's kind of mocking the environment, and the only real way to know is by using a real device. And maybe not go to countryside, but you just basically slow down, get a slow device or something. But yeah, a browser at least lets you mimic it.
Cool. Anyone else? Okay. Thank you very much, Joe.
Cool. Thanks.
Cool. We are going to take a 5-minute break whilst we switch speakers. So go and refresh your drink or whatever, and be back here in 5 minutes. Cheers.
Cool. Cheers, Tim.
live stream signal. Okay. Welcome back, everybody. Cool. So just thanks again to KPV LAB and McGregor Boyall for sponsoring us. Without them, we wouldn't be eating pizza and drinking drinks, so thank you very much. So next speaker is Phil. Phil works for Netlify, which is a tool that I've used many times, and I'm sure many people have used it here too. So I'm really excited that Phil has taken time to come up to Edinburgh, all the way from down south, St Albans in London, to come and speak to us about robust rendering on the web. Cheers.
All right. Well, thanks for having me, first of all. It's great to be here. And thanks, Joe, for getting us off and running. I think I'm going to be overlapping with a couple of bits and pieces. Maybe we'll be disagreeing on some things. Maybe we'll have to fight later on. I don't quite know what the etiquette is. Probably not that. But I should probably start with an apology, because naming things is hard. Naming talks is hard. And I feel like I just lent into the alliteration rather than saying anything meaningful here. You know, generating views as well. I'm not an influencer. I'm not suggesting that we can find ways to get your sites to get lots of likes or views or whatever. That's not what that's about. We'll get into that in a minute. Rendering, we've already heard the term used already, but what does it mean exactly? I think we could probably do with clarifying that. Robust, well, now I sound like a politician or something, or an economist. I don't know what I'm saying there. So we'll maybe get into that as well. Options, I think I'm safe. Web, feel I'm safe. I got my name right, that's good. I do work there, so that's okay. So it's not a complete disaster. But a tiny bit more of an introduction for me. As you already heard, I'm Phil, and according to my family, does anyone else have this job? According to their family, they work in computers. So I think this is what my family think I do, which is sometimes is true, but generally not. So yeah, I work in developer education at Netlify, and yeah, and I love talking about the web, love talking about building with the web, love talking about interesting ways you can build for the web, and maybe that we'll have time for questions at the end of this. If not, we're going to be around afterwards, and so I'm certainly going to be here to chat to, and maybe if we go to the pub as well. But if you'd rather do it later, if a question pops into your mind later, or if you're watching on a live stream, you want to ask a question, I'm in lots of places as at Phil Hawksworth, because that's my name, that's the length of my imagination where it comes to that. I don't know what social media is anymore, but I'm in various places on that. So feel free to ask me questions there should you wish. I should probably stop doing that and probably just instead point people to my website. I have a website, I've had it for 25 years. This is maybe the first example, or the second now, I guess, of how naming is hard. Hawksworks, that's pronounced, because I thought that was cool 25 years ago. Drop the end of my name, put an X on it. What could be cooler than that? Not cool at all. If you say it, no one knows how to spell it. If you spell it, no one knows how to pronounce it. Stupid. But naming is hard, and we'll come to that later. I can prove naming is hard. You've got this slide in your future. This is coming later on. You've seen some of these terms already, but we'll be revisiting those in a bit. But let's talk about rendering for a second, because you've heard the term from Joe already, and you know I've mentioned it in the title. When I'm talking about rendering, I'm talking about generating and outputting HTML or manipulating the DOM in the browser, doing the things that lets the browser create what the user sees. And I go to pains to kind of explain that again, because we bandy the term rendering around quite a lot now, and it could mean a few different things in a few different contexts. I think the first time I used this term publicly was in 2013. I'm not suggesting I invented this term, I just happened upon it. And I was chatting to someone before a conference, and I was saying what I was going to talk about, and I said something or other, rendering on the server, and they just looked at me in the eye and they just laughed in my face, and they said, "Do you mean serving HTML? Is that what you meant?" And that's exactly what I meant. I meant, you know, a server returned HTML, and you know that's not particularly groundbreaking. This is the good old days. You know, we think of servers and clients, and it used to be. I loved building for the web in this era. You put some assets on the server, and when the client came along and asked for it, you'd give it to them, and then the client would render that for them and display that for them. And that was great, and it was nice and simple, and it performed really nicely. But then we got more sophisticated. We got to the point that servers were active. They could, you know, they performed some logic. They had code that ran there, so we could do some computation there. You know, we could combine data and templates and generate the HTML that got returned to the client. So that was rendering, I guess, then. And so things got better because we could have more dynamic views, we could have things that were personalized and a bit more data-driven. But they got worse because there was code running there, so there's an extra point of failure. So it's a bit of a balancing act, and it got a bit more complicated. And then we started adding in the client, we started the ability to do compute there as well with JavaScript, which meant that we could do client-side rendering and manipulate things in the browser as well. So things got better because we could have more dynamic, more responsive, more engaging sites, but things got worse because there's another point of failure there as well. And I mention this because I care very much about robustness. I care about building sites that will live for a long time and they'll be kind of fault tolerant. And robustness, as many of you may know, is a real, in displays. Oh, there we are. Did I imagine that, or did that happen? Okay, it wasn't me just blacking out for a second. Robustness is a big principle on the web that kind of allows us to build things in a fault-tolerant way. You know, the robustness principle, or the rule of least power, as you may know it, is one of the design principles of the web, which, you know, in general suggests that we should choose the least powerful, least sophisticated language to achieve the goal that we're trying to achieve when we're building for the web. Introduce the fewest number of points of failure that we possibly can. So I care about this a lot, and it's always at the back of my mind when I'm thinking about how I'll render a view on the web. And things didn't stay like this, of course. You know, things have evolved since then. You know, I'm very keen now on taking, you know, the active part of the server away and pushing that away from the user, pushing that into a build server. Excuse me. And again, Joe's mentioned this aspect already. So now there's 3 places maybe that things might exist, and you know, we now have serverless compute and things running on the edge, and you know, this is a kind of a simplified view, but you can see there's lots of places where things can happen. We can do work. We need to have this kind of mental model of how we might build things for the web. So I'll return to this as we kind of look at a few terms, and I promise I'll show something that's not just lines and boxes at the end, but I'm not brave enough to do a live demo like some. So the plan is we'll spend about roughly 15 minutes talking about some different rendering patterns and thinking about the pros and cons of them. We'll have about 10 minutes of applying a few of those techniques to one example and thinking about the lessons of that. And then before then, we'll have a few minutes of what my father would call twaddle, which is this, but we're done with that now. So we can get on with this bit. So let's talk about a few bits of rendering and a few bits of terminology. And terminology is something that we can't escape. When we're building things for the web, there's new terminology that arrives every day. I don't know what's new since we started this evening, but I'm sure there's something. And naming is hard, and I told you this was coming. You know, there are a bunch of acronyms that we just can't escape, and there's more being added all the time. So I'm just going to look at a handful of these. Some of them we've heard about before, and some of them I want to just expand on a tiny bit. So let's start here. Let's start with this one, and we've already heard this term before, static site generation. Now, I showed this diagram of, you know, pushing things away from the user to this build server, and this could be your local machine, it could be a server that's dedicated to the job of running a build, it might be a continuous integration server. And CI/CD is another term that we just got to expand on. You know, this is something that's really enabled this idea of static site generation becoming actually a bit more compelling, because we can really reduce the friction in deploying and building a site through CI/CD. So this idea of continuous integration and continuous deployment, where we can see if something has changed, automatically run a build and automate the process of deploying that. That's kind of reduced the friction in publishing things often. And you know, I worked in agencies for many years, and the idea that we would be able to just deploy something very quickly, now it feels commonplace. But we used to have a deploy team who we'd lock down on content and code for a week so that deployment could happen. So the idea now that we've got such little friction in deploying things is a huge enabler, and that's what's kind of led to this kind of resurgence in static site generation, which we've now kind of evolved beyond again. But you know, I really love it because, you know, if you think about this slightly simplified view of, you know, a request on the web where we've got users, you know, clients on the left there, they make a request to our infrastructure to get a view of some web page. And that request hits probably like some load balancers that kind of shape the traffic across a number of different web servers which need to generate a view. In order to do that, they'll distribute their load across a few different database servers, get the data they need, create a view, package that up, return it back down the chain to the client at the end. All of these are places we need to kind of maintain code, update code, deploy code, and all the rest of it. And I love the idea of pre-generating things because it means that we can put those pre-generated assets entirely on a content delivery network, some infrastructure which is designed purely just to serve assets. And so that kind of shortens this chain, takes a lot of the failure points out of it. And this is possible because, as I mentioned, now we can automate the build, we can note when code or content has changed, trigger updates, and these things can happen ahead of time rather than at request time. So I'm a big fan of that. Not only does that mean that we kind of reduce the risk of things going wrong when a user requests something, but also this is great for doing the job once rather than every single time someone requests something. It's great for the carbon footprint of the site. It's great for resilience and many other things as well. So fine, dandy. Let's move on to CSR. Now, you've already heard this, and Joe did a great job of describing this and saying a few things that I really agree with about some of the drawbacks, but also some of the benefits of this. It's been a real enabler, and we've seen a huge adoption of doing things in the client. Harry Roberts, who's a kind of performance consultant, describes CSR as being the fastest way to build the slowest sites. Now, I don't think that's entirely fair. It's certainly something that I've been guilty of, and it's an easy trap to fall into. But it's just, there's more to be aware of. Naturally, this happens where you'd expect, happens in the client. And I just love the fact that kind of Joe at 713 was saying using JavaScript responsibly is one of the kind of the key things. I'm all about that. I think, I'm a massive JavaScript fan. Using it responsibly is the thing to do. When does it get executed? Because it's not just about where, it's also when it gets executed. Well, it gets executed in the browser, but it happens when the assets have arrived, when those have been served from wherever you're serving them from. And often it happens when the user interacts. So it has a slightly different kind of profile in terms of risk and reward than some of the other ways we might be rendering. Okay, I'm moving quickly because I want to get to the point that I'm showing you things that aren't just words. But I wanted to talk about this one. So edge-side rendering. ESR. So we've now got so many different serverless runtimes that are available to us that we can do things a little bit closer to the user. So we're kind of looking at this diagram again. It's not something that's happening in the build infrastructure. It's not happening in the client. It's not happening on a server that we maintain. It's happening at the edge of the network. And this kind of idea of serverless functions that we can use to manipulate requests and responses and enhance the responses that get sent to the user, this is a real game changer, I think. And this happens, here in this kind of infrastructure, out at the edge of the network, but it's code that isn't bound to the notion of a physical or a virtual server. It really is code that you push to infrastructure that you have. You don't maintain in any way. It's infrastructure as a service, if you like. Now, this is great for enhancing responses with things like, stock prices or stock levels, doing personalization or authentication, the kind of thing that you can push a little bit closer to the user and kind of enhance something that's been pre-generated ahead of time. Okay, this is the one. This is the one where we might have to arm wrestle, and I don't do well at that. SSR, server-side rendering. Now, this is where that happens, right? It happens in the server. And it happens at request time. It's not happening in a build server. It's not happening ahead of time. It's happening in the server at response time. But that's if I'm being a bit of a purist. And I think Joe described this in ways that I hear all the time, and I think it makes a lot of sense. It was across various different places, right? It could be in a build server, because a build server is a server, and it could be elsewhere. And I think this is described this way a lot because we've got client side and the other side, and that's kind of the server side in our idea of a client-server model, which makes perfect sense. So I often hear server-side rendering being used to describe several different things. I guess it's the not client side. Naming is hard. There we go. It's another kind of bit of evidence of that. But I've always thought of it as something that happens at request time, but in a physical server. But I think it's reasonable to be a little bit pragmatic about this because, if I'm going to get too puritanical about it, it's not really just happening in the server. I think you could argue that it's happening at the edge as well, because this is not in a client, it's not at a build server, it's something in between. And the fact that it's not in a physical server, does that matter to us? Logically, it's the same. So I don't know, we'll call it a tie. We disagree a little bit, but I think there's some pragmatism that needs to go beyond being the purist and saying this is where it is. But SSR is just one that I think we sometimes trip up on in exactly what it means. Okay, bunch of terminology. So the obvious question, which is best? And it depends, which is an answer I would get criticized for a lot, and that would be reasonable. But I think it depends is a really, really important question, answer to questions if it provokes this question. It depends on what, because then we're getting into the nub of it. And I think this is a really important question to ask. So I'm glad you did. And so I'd remind you kind of the rule of least power and trying to find ways that introduce the least complexity whenever we're designing the way that we'd build things for the web. Now, deciding demands a bunch of questions, and the most important question, I think, is what are the requirements? Now, I'm conscious that standing in front of a monochromatic slide that says what are the requirements isn't the stuff that dreams are made of for you. I think you had other things in your mind for this evening, but this is so important. Choosing a tool before we know what the requirements of the project are is it's where trouble starts. And it's very easy to choose tools based on how much fun they are to use, or how in demand they are, or how exciting they might be to use. But understanding the requirements is the most important thing, I think, before we choose any of our approaches and the tools that we might use to fulfill those. What is the best tool for digging a hole? It depends. Great for quarries, bad for the greenhouse. So I'm flogging a dead horse a little bit, but you get the point. But I mentioned a bit of pragmatism earlier on and thinking about server-side rendering. And I kind of go back to this. I got into a bit of a debate on Twitter, which is where all good, reasonable debate happens. I got into a bit of discussion there. And this is what I was trying to suggest after people were trying to decide whether or not they should do serverless or SSR or what they should do. And I said server-side doesn't have to mean server full. If I can, I do things in advance. I'll always do that. If I can't do things in advance, but I can do things serverless, I will. And if I can't do that, but I can add a server, I will. So I'm always thinking about adding things in increments, starting with the simplest thing that satisfies the goals, and then gradually adding those things on. Working in increments, I think, is really important. And speaking of increments, we should talk about yet more acronyms. I do have good news. Not all of these are real acronyms for things on the web. The fifth one can go away. It's just more of a sentiment. But these all, the other good news up here is that 3 of these basically mean the same thing, and the other one kind of basically means the same thing. So we can cover a lot quite quickly here. Yeah, ISR, you heard about ISR earlier on. Let's talk about these other 3 as well first. So DPR, ODB, DSG. Let's do it. So DPR. So this is an idea again about incrementally building things out, as you heard a little bit earlier on. It was originally created as a proposal by Netlify as an approach to, we're trying to standardize a way of gradually having like a long tail to builds, long tail to rendering. So rather than generating all of the assets within a deploy and within a build, we create a bunch of those things up front, and then later on, when things are requested, we'd generate those and persist those assets as well. So it was distributed between build time and request time. And the tool that we built to implement that, the product we built, was something called on-demand builders, which is serverless functions that have a little handler that will create this kind of behavior, this kind of caching behavior, if you like. So this is our product that implemented that standard, that proposal. The Gatsby team came along and they did exactly the same thing, but their product was called Defer Static Generation, which I massively prefer as a name. I think it's way more descriptive. It means the same thing, but it's deferring the generation of the assets until later on. These 3 terms all effectively mean the same thing. None of them quite nail it for me, but the idea is don't generate it in the build, wait until the first time it's requested, then generate it, and add it to what was built earlier, so those could be cached forever for subsequent requests. The acronym for that is this, because as I said, naming is hard. I can't pronounce that, I won't try. But this is made possible, again, by this idea of serverless runtimes being able to live out on the edge of the network and them to have this same workflow as building the assets that are maybe pre-generated. It creates this lovely workflow that's decoupled from your infrastructure. You can push things to Git, off they go, they get deployed, happy days. We should talk about this one as well, ISR. So ISR, as you heard earlier on, was popularized by the Next framework. It's an implementation of stay while revalidate, which is a caching standard behavior. The idea being that the asset might exist in the build, but it's not guaranteed to be up to date. So you'll return that while you go off, refresh the version that's there in your cache, and then potentially update that to the viewer, the requester, or it'll be there a bit fresher for the next person that comes along. The reason I mentioned that ISR basically can be the same as the other things I mentioned is because you can change the settings of that. So you can change the behavior so that effectively it works in exactly the same way as these other things where they request things, they serve them, they generate them the first time they're ever requested, and they cache those in the build in perpetuity. So those things, if this helps, not going to pronounce that either, but they're effectively the same thing. So you might be asking which one of those is best, Phil, and the answer, of course, is it depends. So let's work on an example. Let's look at something a bit practical so you're not just looking at lines and boxes. I like playing to learn things. I like making things and experimenting on my own site and in silly experiments before to help me learn about the best ways to treat something before I then think about how they might be deployed in production. And so I kind of conjured my own use case for this, which is one provoked by nothing in particular, but I decided to take all of my tweets and then self-host those rather than depending on Twitter to be around forever. Is it still around? Is it? It is? Okay. So I thought I'd create something that adds all of my tweets to my own site. So I had some requirements for that I created myself, but let's go through them. I wanted each of these posts, there's 24,000 or so tweets. Each of those needed a URL of its own, a distinct URL. I wanted an index page that would kind of paginate and list all of these things so that each one then had a URL that I could discover and go and find it, but it's effectively a listing page. I wanted the ability to search tweets. When we're thinking about static generation or pre-generation of a site, search is sometimes one of those things we think, well, how are we going to do that? We need something a bit more active to do that. So I wanted the ability to do that. I wanted to retain a reasonable build time. Now, this is going on my blog, which has got, I don't know, a couple of hundred pages, something like that. I didn't want to have to wait a long time for the build to run, so I wanted to kind of retain that. This is also a good example or a good test for a more common use case of maybe like an e-commerce site or a site that's got lots and lots of pages, tens of thousands, hundreds of thousands of pages. Typically, that's an area we think, well, we can't pre-generate this. So I wanted to test that out here. I wanted to avoid client-side rendering if possible, again, because I wanted to keep it as robust as possible, introduce as few moving parts as possible, do things up front if I could. And I wanted a logical model that fits in my head. Now, this sounds really flippant, but this mattered to me a great deal because, I kind of have this idea that simpler is better, but we should challenge that a little bit. We should interrogate that. Simpler how and better for who. I could easily have reached for maybe a framework that would do a lot of these things by magic for me, but I'm scared of magic. I want to make sure I understand what is actually happening. If there is a good abstraction that's going on, I want to be able to understand that and have a good mental model of that. So this is important to me. Thinking of abstraction as well, did anyone ever write code like this? Everyone write a function like this? Maybe this exact thing? A couple of nods a couple of nods around the room. I think this is one of the first little library helpers I wrote for myself, soon followed by this one, which does something slightly different. If you know, you know. This was like the thinnest end of the wedge before frameworks went like this, and I started using other people's things. Anyway, that's by the by. So yeah, I wanted a logical model that fits in my head, so when I return to it later, I could understand what's happening, and a year later, I still know what's going on. That's a really important point, I think. So how did I tackle it? Well, I thought I'd use some static site generation, because that's what my site did already. I would add some on-demand builders, so ISR or something of that ilk. And I'd use some edge-side rendering as well to do some of these things as well. So this is what this looks like. I said I was going to show you something that's not lines and boxes, and this is just some more lines and boxes. There are pictures to come, I promise. So this is how this works. So I have a build that looks at some templates and some abstracted data. This is a blob of JSON. This is the archive of all of my social media posts. And when the build runs, it takes those things, munges them together, and it outputs a bunch of assets. It's a website, and that can get served from any kind of static host. And that includes all the content pages that were there before, but then also these social media index pages, if you like, the paginated views of all of my content pages. So when a user comes along, they request it, it's there already, and they get that back. And it looks something like this, and I don't think this is going to be too much of a surprise. It's a paginated list. And so, here are all of the tweets that I've posted, and you can paginate through them. You get a URL for each of these pages. Go to the last one. So it's about 1,000 new pages that it added to my site. Nothing groundbreaking, but it's satisfying one of my requirements. My other one was about the build. Well, the build duration was about 2 seconds to run the build. Locally on my machine, it would run about 1 second because it was, again, about 1,100 URLs, something like that. In Netlify, where I unsurprisingly host my site, the build would run in about 2 seconds, keeping me honest, there it is behind there. But the build itself, the deploy, would take about 40 seconds with bootstrapping the environment, propagating all of the assets. This felt like it was still reasonable. Okay, good. How about then the idea of a URL for every one of those 24,000 pages? Well, here I'd use on-demand builders, so this kind of deferred static generation model. So the user would hit the URL of one of those tweets, and that would then go off to the same set of data and the same templates that I already had that I used for the generation of the site. It would, on demand, create that view, and it wouldn't return it to the user. It would add it to the assets that were in the most recent deploy, cache those for every subsequent user, and then it would be returned. So we'd get a page viewing every post that would gradually get populated as these were requested. So this is what that looks like. I go to one of the tweets on my paginated view, I hit the permalink, and it might take like 100 milliseconds or something to generate that for the first person, but then after that it's cached, so subsequent users can see this stuff, and this is gold, isn't it? Starting my day by making the perfect piece of hot buttered toast. It's important that I archive these tweets. I didn't want them to go away. I think you'll agree that's important. Each one gets a URL, so I can those persist. Since we covered some of these things earlier on, I thought I might show you some code. Thought I might have time. I'm going to do it anyway. I think I've just about got time. You probably can't see that too well at the back, but I can pre-see it for you. So this is the function that renders the view of one of those tweets. So just to summarize, I'm pulling in a little helper here, a little function that's provided by Netlify that adds that persistent functionality. This is the thing that adds it to the deploy, adds it to the cache, makes it a builder function. So we just wrap what we're going to create in this little builder wrapper, but the real meat of what's going on is inside it. So I require the set of my data. This is just the tweets JSON file. It's pretty large. It was about 12 meg, I think, but it was. But there it is. It's a bit of JSON that I would request and query. I had a string literal, which is the template of the page. But then my handler function would do kind of what you'd imagine. It would get from the URL that was making the request what the ID of the tweet is that I wanted to get. It would look that up from our blob of JSON that we pulled in, and it would inject that into our template and return it. And that's it. That's the whole function that does that. So this is just a function file that sits in a folder as part of my deploy that then provides that on-demand builder. Okay, so what's next? Search. I wanted to be able to search things. Here I decided I was going to add to what I already had some edge-side rendering. The idea here being that when a user posts a request to the search form, they're searching for a particular thing, probably more about that hot buttered toast, I would imagine. They would hit the function which is our edge side renderer. That would do exactly the same thing as the other things. It would go and look at the JSON data. It would do some very simple string matching to find all of the entries that applied. And it would inject those into a template, and it would just return that directly to the user as a search results page. This is just using all of the same mechanics that were there before, but now doing this on demand, close to the edge, close to the user, so it's a nice and fast response. So I search for the word render there, and I get 169 hits from all of my short of 24,000 tweets. They're not all about rendering though. I don't know if you can read that. This is one from about a year ago. My wife keeps sending me random pictures of our cat rendered as a cuddly toy, and I'm here for it. Again, I told you this archive is important. If you want to know more, and I know you do, this is what I'm talking about. This is the kind of stuff that I get while I'm away, or this. They say that AI is the future. I don't know. What the hell is that? If you're not a cat person, don't worry, she did it for next door's dog as well. Anywho, this is kind of beside the point. One of the things that enables this is this abstraction, the fact that we can decouple the JSON and use it both at build time and at request time. And you know, I saw that the last session here, there were talks about using Google Sheets as a data source. Abstracting data in that way means that we can pull them in lots of different ways. I'm really kind of interested in that. You've already heard about Astro today, and there are lots of frameworks that kind of give this kind of rendering sugar, if you like. These help us to do a bunch of the different types of rendering. But I think it's really important we understand what those are and how we might use them. At Netlify, we're really excited about kind of building out the underlying primitives, some of the things that I was using directly there, so that those frameworks can, you know, enable those patterns and some other patterns as well, and future frameworks that we don't know about yet, or no frameworks if you want to do things directly. If you want to learn more about some of these things, we're building out a bit of a hub of resources at the moment for developers that's kind of growing slowly with lots of kind of deep articles. My colleague Matt Kane wrote something recently about how to do ISR and advanced caching on Remix. There's kind of interesting things if you want to get into the weeds of these things and get in there a bit more. I'm kind of out of time, so I'm going to rattle through these questions really quickly to summarize. I'm all about building the web responsibly, kind of just taking liberties with what Joe said earlier on, expanding on that a little bit, really kind of plus oneing what he said. There's no one right way to do these things, right? There's lots of different ways that we can build these things out and achieve the goals that we've got. I'm a big fan of doing the work ahead of time if you can, and not coupling the work to the volume of traffic you've got, if at all possible, for lots and lots of reasons. Some of them are more obvious than others, but robustness and kind of fault tolerance, performance, energy efficiency, and so on. You can mix and match these rendering methods, as I kind of just showed, but critically, I just don't think you should ever choose one tool or another until you understand the requirements and know how to use those most effectively. Last two things, not all my tweets are pure gold, I think I proved that, and naming is hard. Cool, thanks ever so much, thanks a lot.
Thanks, that was great.
Don't know if we've got any time for questions?
Yeah,
or?
sure, why not? Yeah, I think it's great. I think if you've been in web dev for a while, you can sort of recognize that a lot of these things arise for solving particular problems that you've got, and you know, in a year or two, the problems we've got right now will be solved by someone else.
Or we'll reintroduce problems that we've solved once in the past because we've got a new solution for something else. Yeah.
So it's great. It's great to see and hear it from that. So does anybody have any questions about this? Should we start with Orkan and then?
Thanks for talk.
Yeah.
What's about like I changed, I don't know, one of the component or something that is in all the pages, and how they're getting invalidated the page in incremental rendering.
Yeah, so that's a great question. Yeah, so if you are changing a component that's used in lots and lots of pages, is it wasteful to regenerate that? And that again comes down to, I mean, the short answer is yes, that's going to regenerate all the pages. If you use that everywhere, you know, updating the data in the footer of every page on a site that's got 100,000 URLs, potentially you're regenerating all of that. Now that's where I would lean on choosing what to pre-generate and what to render on demand. So if you can reduce the number of URLs that are in your build, then that means that the consequences of that are much fewer. So in this example, you know, I don't have 24 25,000 URLs in my site. I've got 1,000 URLs in my site. So I don't mind rerunning that build because it's a short build, because that means I could, that is because I've been able to take some of those things out of the build and do those as a long tail, because they might not get lots and lots of traffic, or some of them might not be viewed at all between deploys. So I can offset that. So that's one way of doing that. That's one way of kind of alleviating that risk. Another is by using something like edge-side rendering. So if you can think of some things that might get updated frequently, such as stock levels or price data or those kind of things, those could be treated almost like progressive enhancements for content in your site. So you could pre-generate all of the site structure, all of your content pages, your product pages, for instance, but then have an area which you enhance with edge rendering. So as the request comes through, the response comes through, you inject one thing in there. That's another way of doing that. Often that's been done with client-side rendering to get around that, but I think that leads to things like flashes of unstyled content or changes in layouts or layout shifts or what have you. So if you can do it upstream of the client, like somewhere like the edge, I think that's all the better. But yeah, my long answer to your short question is offset that as much as possible by taking as many things as you can out of that kind of critical rendering, but server-side, if you like. It depends. I could have just said it depends, and then you just start throwing things at me.
And another question. Can I set the rule for invalidation of the page? For example, time expiring.
You can, yeah, you can. So I almost said it depends again, but no, you can do that. And so the level to which we so this is the question about on Netlify, really, right, as much as anything else. So the level to which we expose that primitive at the moment, I'm not quite sure, because you can certainly set things like cache invalidation headers, cache durations and what have you, set custom headers, but sending a request to say, I'm going to time out that asset that's one of my on-demand views, for instance, to really have very fine control over ISR. We give that to the frameworks at the moment, but I confess I can't remember if we expose that API directly to everybody. So through the frameworks, yes, and I think I won't get in trouble for saying, if not now, soon, for anyone at a low level through the API as well. But yeah, it's a really important ability to have, yeah.
Hello.
Hello.
I might have missed it, but in case I did miss it, what framework or what tool did you use to build your own website? Oh,
I'm so sorry. Yeah, so yeah, you didn't miss it, I forgot to say. So I built that with 11T. I'm a big fan of 11T because in a similar way to Astro, you kind of have to opt in for things. It's by default, it generates HTML, manages data and templates together. It's really good and fast at doing that. And I'd be very tempted these days to maybe use Astro in the same way and just say, give me the HTML. But yeah, that was 11T, and then the other bits and pieces were effectively just like raw serverless functions or edge functions, not through a framework, just kind of going direct.
Thank you.
Yep, you bet. Any more? Yeah.
Forgive me if I've misunderstood, but when you were talking about the tweets and when someone views them, it then gets added to the cache.
Yes.
At what point does that cache get cleared? Does it just keep growing in perpetuity?
Yeah, that's a great question. So yeah, so just in case not everyone could hear that, the question was when new pages get added to the cache, for how long are they cached and how big does that cache get? That cache, so the behavior there with on-demand builders is that when a request comes in for a resource that hasn't been generated yet, we generate that new thing, we add that to the cache, it's adding it to that deploys cache. So effectively, the next time you deploy your site, those get scrubbed because you're creating a new atomic immutable deploy of your site. So those are no longer cached. So the clock starts again, if you like. So it means that the build stays the same each time, and then over time the cache gets bigger and bigger and bigger until you reset it. So people are going to pay the penalty for that first request of that being generated for the first time. But as you saw, I mean, here's that phrase again, it depends on the view and how much complexity there is in that, for how long that first render of that asset might take. In my example, you wouldn't know that it wasn't pre-cached, but yeah, so you gradually kind of seed reseed that cache over time. It resets at every deploy. I'm giving very long answers to short questions. It's like I'm trying to stop you going to the pub. I'm really sorry. Yes, yeah, then I'll go.
Yeah. Cool. Any more questions at all? Awesome. Cool. Thanks, Phil.
Nice one. Thanks very much.
Right. So thank you for coming tonight. We have the next EdinburghJS with Daniel. You can find out about Nuxt. We haven't exactly agreed what exactly you're going to be talking about, but I'm sure that will feature. So make sure you go to the Meetup group and sign up for that. GlasgowJS, the next one, there are only a few places left, so if you want to go to that, RSVP as soon as you can. We will be live streaming it. That will be on TensorFlow.js and developing React Native apps with Expo. Looking forward to that. If you want a bulletin of events that happen every week in Scotland, go to scottishtechnology.club. I just look through Eventbrite, look through Meetup, and dump a whole list by date and by city. So check that out. There is a Discord server link there, so people chat about stuff, chat about tonight, share photos from tonight. If you have taken photos of this evening, it's very useful for you to share them on Twitter and on LinkedIn and tag in our sponsors, because they have sponsored and paid for the pizza. So it just helps out future us drinking and eating essentially for free again, which is very nice. Cool. After this, people tend to head to the Fountainbridge Fox, which is a pub just along the road for drinks. Thank you for coming, and I hope to see you there. Cheers.